There's a common misconception that in electric guitars, the sound of the string is collected like how a microphone collects your voice. But that's clearly not the case because if I talk directly into the part of the guitar that collects sound called the pickup, like this, then no sound actually happens. But if I were to play something like this, then there's actually sound. So why is this so? Well, to figure this out, we have to understand the mechanism behind our pickup. And the best way to do so is by examining the properties. So here, I have a paperclip, a metallic paperclip, and I'm going to be placing it directly on the pickup. And you can see it actually sticks right on. So that probably means that the pickup is magnetic. Well, with this information, we can now safely investigate the physics principle behind this mechanism.
You see, magnetic fields are actually inseparable from electricity. When there is one, there will always be another. According to Faraday's law, electrical voltage can be generated from a change in magnetic field. So we have changing flux over changing time. So in our case, if we look at this diagram, we can see that there was initially a field here, and the vibration of the string causes a change through the flux of the system because it cuts through the field. In the induced magnetic field, a change in flux in turn generates a voltage, which is processed into sound by this coil. Now, vibrations of different strength will play a factor to the voltage, as well as the number of coils the pickup has. Together, these factors contribute to the voltage, which is the sound and the tone of the signal.
So you're probably wondering, well, a metallic paperclip's not so different from our metallic guitar strings. So could we do the same thing? Well, the answer is yes. I'm not going to be playing any of the guitar strings, and I have the metallic paperclip from earlier. I'm going to be holding it like this, and I'll be flicking it like this so I can create a vibration. Well, if I bring forth to the pickup, this is what happens. So you can see that physically they're indifferent. They're both objects that interrupt our magnetic field, creating the voltage, which is, in turn, the sound.
Furthermore, there are many more interesting applications of induction in the world of electrical instruments. If we look at this diagram here, for example, on the left we have early pickups. They used a single coil with a small number of turns, which produced a lower EMF and was more easily affected by magnetic interference of other metals and electricity. So, by applying Faraday's law, engineers increased the number of turns to raise the voltage. But this also increased hum from disturbances. So, on the right here, we have the humbucker style pickups, which solves the problem by using two oppositely winded coils, one on top, one on the bottom, which will cancel out the unwanted noise. But they also maintain a similar output because the number of turns here is doubled. But the coils is also doubled. So in turn, it's actually the same. We have the same voltage. The implementation of Faraday's law in induction is also still being innovated by sound engineers, like with the technique known as coil splitting, which lets the guitarist freely toggle between the mentioned single and humbucking modes. This happens with a switch that disengages sections of the coil, as seen here. So this part, it says it's on, so this is a humbucker, but then this part is disengaged. The coil here is disengaged, turning it back into a single coil. So in turn, these will actually have slightly different voltages. And this lets the player have freedom to choose between the single modes and the double modes. Another piece of technology that uses the Faraday's law is this guitar pick that claims to have a magnetic tip, so it can actually directly interfere with the field strength of the pickup. Let's have a listen at it.
Simply by slapping the magnetic fields.
I couldn't quite get my hands on the X pick that they use in the video, but here, I have a little bit magnet, and I'm going to be trying the same thing. And if you listen carefully, you might be able to hear the induced voltage. And there you have it. You now know how magnetic induction is used to capture and electrify the sound of this instrument. Now, if we were to return back to our microphone misconception, how might you think that mics capture sound? Well, it turns out mics and electric guitars aren't so different after all. In fact, they both use magnetic induction. It turns out that sound vibrates a tiny metal strip, which then distorts a magnetic field inside of the mic, which will in turn induce voltage. Now, I definitely learned something new while making this video, and I hope you did too.